So today is lesson 13. So I've gotten about just over 60% of the assignment 4 submissions. I should be able to mark those fairly quickly. If possible, I'll actually try and get them marked by the weekend, if at all possible. If you still have not submitted assignment 4, please make sure that you submit today so that I have something to mark and some grade that I can give you so that I am not left with no option but to assign a 0. So today we're going to talk about the final exam, which we'll have during class next Thursday from 11 to 2 p.m. We're going to explore some basic terminology involved in working with APIs, and then we're going to use Visual Studio to quickly generate a simple API, and then we're going to test it out. We're also going to use it, so we're going to install a tool called Postman that will let us make requests to our API. And then we're also going to look at documenting an API with a tool called Swagger and a specification called Open API. So not only do we want to build our API, but we need to document it so that other developers would understand how to work with our API. Okay, so we've got a fairly small group today. So we may have to adjust a little bit what happens in our next activity. That's okay. So our final exam will be held in class next week. I will be sure to open the WebEx room early at 10:50 at the latest. I'll have the WebEx room open. The exam, I'll go over the instructions right at 11, and you'll have until 2 o'clock. The exam format will be really similar to the midterm exam. So it's all practical. You have access to all of your course resources. You will be asked to commit to GitHub every 30 minutes through the exam so that I can see the progress of your work. I will probably provide a database for you, and I may even provide a starter project for you to download from GitHub that you will then make modifications to. There will be several different versions of the exam, again, as there was with the midterm exam. And it will focus more on the content from the latter half of the course. So things like security, unit testing, web API, which we're gonna do today. There will still be some items from the first half of the course, but the majority of the marks will focus on content from the second half of the course. You will not need to use Azure at all. You won't need to use Azure or Smarter ASP. So don't worry. If your Azure credits have expired, if you don't have a Smarter ASP account, you're not going to need those. I will download and run everybody's project locally. Are there any questions at all about the final exam? Colton, I just saw your message. Yes, I'm really glad we get to be back in class as well. Be nice to actually get to meet people in person. Go grab a coffee on a break, that kind of thing. Yes, I bet. So any questions from anybody about next week's exam?
No, not at the moment. So if so you're going to IFOTN to your account and copy it as part of an exam, is that right?
It could be. So if that's the case, yeah, I might post like a starter project there, Chris, like one that's maybe partly built. And you would then just download it and extract the zip file, and then you could open it in Visual Studio, and then you would work from there. I have done that in the past. I haven't yet decided. I'm leaning towards doing that because, again, I don't think I really need to assess you at this point on setting up a new project from the beginning. I think I've assessed that several times now in your midterm exam and in your assignments. So most likely I will provide a project to start with so that you're not building one from scratch. I don't think I really need to test you on setting up a web project in Visual Studio anymore. I'm inclined to give you a project and then just have you make modifications to it. So that's most likely the structure. Anybody else? Yes, David, thank you for that reminder. I will. Yes, I do just want to make sure that it is you in the room doing your exam. You won't need to leave your cameras on the full time, but yeah, maybe just when you come in and once I go through the instructions, we can turn them off. Yes, make sure you brush and floss. Matthew, good question. The other thing that you should practice, I think, would just be making some customizations to the scaffolded views and controllers. So doing things like, being able to sort data in a controller method that fetches from the database, or being able to clean up things in the view that aren't maybe totally polished that you wouldn't hand off to a client as done. Okay, so if you look at the customizations that we've made, probably like through lessons 5, 6, and then into the shopping cart, where we scaffolded things and then we customized them, that would be good practice. So a good way to practice would be you could go through your assignment and look at, okay, if I was going to actually publish this project that I did, like what sort of cleanup items would I do? Where I might be making some small adjustments either in the views or in some of the scaffolded code in the controller, just to make things look a little better, make them function a little more smoothly. Does that help? Okay. So yeah, use your project. You can work on your local project, and I would suggest, make yourself a list. Okay, what else could I do with this? How would I make this better? And use that as a study tool. Do that work, even collaborate with a classmate, share projects and give each other some suggestions. Say, Matthew, maybe you say to Chris, hey, Chris, in your project, maybe you might want to make these changes or these additions. Work with a partner and improve each other's projects. And maybe work through some of this stuff. I think that would probably be the best way because it's a practical exam. That would actually be probably the best kind of simulation for what you'll actually be doing during the exam. Right? Like there are even things with our pet shop we could have improved, but we didn't have time. So there may be some other things in there you could see, oh, well, it would make sense to do it this way or to add this little thing. Okay. So if other questions from the exam come up, please let me know. So we've worked with APIs a little bit already. I was going to do this as a group activity, but we'll maybe just do this kind of collaboratively. So our pet store, we're actually using a few different APIs right now. What APIs have we already integrated into our pet store? I can think of, I think 3. If you open up, we can even open up our pet store project. So we've done a little bit of API integration here. Can you think of, or can you name one or more of the APIs that we've included in our project? Okay, that's one. That's right, Colton. Right? So Google login. So we're leveraging the Google login API so that we can let somebody log in with their Google account. That was one. Yep. What other? I guess in a way, Colton, we could consider Bootstrap. I wasn't thinking about that, but yeah. Oh, that's interesting. Okay. I'm not sure why this died, but this was working. What API are we using here? Yeah, we're using Stripe, the Stripe payment API. So we're using the Stripe payment service. At least we're trying to. So our application right now, we are consuming two APIs. What we're going to do today is we want to actually build our own API that another application can consume. So I think we know what an API is, right? It's an application programming interface. In really basic terms, it's just a way for two different programs to talk to each other. We even looked at this last semester in our PHP course. We integrated, for example, the reCAPTCHA library from Google. But I want to wanted to find a couple of other important terms. So here's what I want you to do. I'm going to give you a minute to do that, a couple minutes to do this. I will pause my recording. I want you to choose any one of these terms, either REST, PUT, URI, or HTTP status code 400. I want each student to just choose one of these terms. I want you to take about 3 minutes. See if you can find a definition online for what the term means. Just pick one of them and then put your definition in the chat. Okay, so before we can build APIs, we need to get clear on what these terms mean. REST, PUT, URI, and an HTTP status code of 400. So pick one term, use your search engine skills, and go find a simple definition that we can understand, not an overly technical definition. I'm going to give you 3 minutes to do this. Please throw your response in the chat. We can just go over this. Okay, so Chris found created simple definition. So an API is a software or an interface, I'll just add, that allows two apps to communicate with each other. So for example, okay, thanks, Matthew. I will add that as well. Let's see a few other messages. Sorry, I'll just update this quickly with the rest of our responses. And thanks for that one, David, as well. I will add that. So an API just lets two different programs talk to one another. So in the case of our pet store, right, our Google login lets us, our web.NET application, talk to Google's login service so that we can use its login feature. The Stripe API lets our application send credit card payments that Stripe will authorize for us. So REST it's an architectural pattern. Okay, so it's an architectural style made for the web. So kind of like MVC is a pattern for application building, REST is it's a pattern primarily for the development of web services. So it stands for representational state transfer. So it's for making an API that uses HTTP requests to access and use data. So all REST APIs follow a certain pattern, much like all MVC apps, regardless of the language they're built in, they follow a certain pattern. So REST is kind of the standard architecture. It's the standard way that APIs, most web APIs, are created today. And so for example, if we want to retrieve resources, we'll use an HTTP GET request. If we want to create a new resource, we use a POST request. PUT is typically used for updating, and delete, well, delete is self-explanatory. So when we see the method, HTTP method PUT, as David said, that's used for modifying a resource. So it's for doing an update. Now we can use a POST method, but most REST services will use a PUT method when they want to do updates. Okay, so we have create, read, update, and delete, and REST methods for that would be POST, GET, put and delete. Okay, a URI, it's a uniform resource identifier. So it's a generic term for resources connected to the World Wide Web. And the most common form is a uniform resource locator, a URL. So here's a question for you. This is a great job interview question for a young developer, junior developer. What's the difference between a URI and a URL? They're very similar. They're not exactly the same. Any ideas? I mean, feel free to guess. It's kind of a tricky question. So we've got URIs and URLs. What's the difference? Okay, URL is the address part on the URI. That's a good guess, Colton. You're not too far off. Not exactly. Raymond says the locator has you thinking it's more for the explicit search of an address. Again, you're kind of warm. I'll give you a little hint. All URLs are URIs, but not all URIs are URLs. So a URI is kind of like a parent object that every URL is by definition a URI, but we can have URIs that are not URLs. I may be able to show you an example. So basically, a URI is a uniform resource. Okay, Jordan says URIs all contain URLs and URNs, and URLs know the location of the resource. The URL is the specific part of the identifier. Not exactly, David. The URL is one type of URI, and it's the most common one. So it's basically a resource that can be identified in a browser with an HTTP path, right? That's a uniform resource locator. So by definition, that's also a URI. We can have URIs, uniform resource identifiers, that are not browsable through HTTP. Okay, so yeah, Fatima said, for example, I'll just put this over here. So something like an ISBN number. This is a URI. It uniquely identifies this book, but this is not a web address. Right? We can't put in this ISBN number in my browser. Right? And so we can see, yeah, there's a good resource, Fatima. Right? So something like a book ISBN number is a URI, but it's not a URL. So URI schemes that start with HTTP, HTTPS, those are URLs, but there are other URIs that are not. I can show you actually another example of a URI. So this is an Android app I built in class a few years ago. Right, so in here, so this is a profile screen in a little Android app I built in my Android class. So on the profile, when we could use the camera on the phone to take a photo And then the file path to that photo was a URI. So it was a location in storage on an Android device. So it was a unique location of where that file lived, but it wasn't a URL. It wasn't an HTTP path. So you couldn't access it. You couldn't access it through a browser, for example. Okay. So when we talk about APIs, most methods have what's called an endpoint. So that tells us where to access a specific method within the API. Now, usually, yes, if it's a web service, those are URLs. But just keep in mind that URIs don't have to be URLs. Does that clarify the difference a little bit? Give me a thumbs up if that makes sense. Okay. Thank you, Jordan. And then lastly, thanks, Raymond. Lastly, we've got HTTP status code 400. So 400 means bad request. Thanks, Felix. So if we call an API method, but we don't send the method what it needs, we're going to get a bad request. So for example, something like this. We can look at a common API here. Let's actually go to the Spotify API. Okay. So for example, if we wanted to get an album, here's their endpoint that uses the get method, and it's albums with an ID parameter. So if we tried to call this method but didn't pass in an ID, then we'd probably get a 400 bad request because we cannot get the album without the ID. Actually, I guess we could. We'd get all the albums. But this one, for example, the ID would be required. If we wanted to get all the tracks on an album, we would get a 400 response if we do not include the ID parameter. Okay, so I'll just save those notes here. So we're going to refer to a number of these things as we build our API. So Visual Studio makes building an API really easy. I'm going to close all my files, close all my tabs, and I'm going to make a new API controller. So inside our controllers folder, I'm going to right-click, and I'm going to add a new folder inside. So we're going to create a controller, but we're going to put it in a subfolder. So I'm going to make a subfolder here, which I will call API. Open that. So now I've got this empty folder here underneath my controllers folder. I'm now going to right-click my API folder, and I'm going to add a controller. Now, when this opens, it defaults to the MVC section here on the left, and we've been working with some of these templates before. We've used the MVC empty controller, and we've used the MVC controller with Views using Entity Framework. We don't want these this time. We're not building an MVC controller. We are building an API controller. So there is no front end. There are no views attached. And we're going to pick an API controller with actions using Entity Framework. Well, what does this do? It builds an API controller with REST actions. We just talked about what REST is, with actions to create, read, update, delete, and list from an Entity Framework data context. So this is going to scaffold a controller, and it's going to give us 5 methods. 2 get methods, one for reading a single object and one for reading a list of objects, a post method for creating new records, a put method for updating, and delete is self-explanatory. So we'll pick this API controller with actions using Entity Framework, and we'll add it. And I am going to pick the pet model. And the data context and controller name, those should get populated automatically. So all I should have to do here is choose my pet model and then click add. So this is going to create a second file with the name of pets controller. We've already got one, but this is our MVC controller. And this is now our API controller. So they're in different folders, which means we can have two files with that same name. So Visual Studio is going to generate this file, and it looks sort of like the other controller. Here's the pets controller that we scaffolded in class a couple of months ago. That has methods that I think we're all familiar with: index, details, create, edit, and delete. And here's our API controller. So it's similar. What are some of the differences that you see in the API controller? Excuse me. The overall functionality is quite similar, but there are some differences in the code. What do you notice? Okay, yeah, the root. That's one thing, Colton. So notice the path to this is going to be prefixed with API/. Okay, that's one thing that's different. Anything else you notice that's different in this controller from the things that we're used to seeing? That's one, is the root. Okay, yep. It's in the controllers.api. This is what allows us to have two files, two classes, both called pets controller. We see this. Each file has the same name, but they're in different namespaces. So that allows us to have two classes with the same name. Anything else you notice that's different? There's a couple of other important differences between our web controller and our API controller. Functionality is generally the same. What else do you see that's different? Look at the ends of the methods, the bottom of the API methods. How are they different? Thank you, David. That's right. All of our methods in our web controller return views, right? And they return a view, and most of them return data along with the view. But here, in our API, it only returns the data. There's no views involved. So they return data, or they just return HTTP status code. It's like we said, 400 bad request. We can see it returns here. So if the API doesn't return views, what format? So for example, here, when this returns a list of pets, what format do you think this comes in? If we call this method, it queries the database, gets a list of pets, and returns the list. But what does that list look like if there's no view? What data format do you think do most APIs use when they're exchanging data between applications? There's a common standard format that you guys know. It's a type of array and a type of an object. It's using a particular language, though. There's a standard language for APIs, for REST APIs. Yeah, thank you, Tushar. So these are going to return JSON objects. So yes, David, you're correct. It is an array or an object in JSON format, JavaScript object notation. So that's the standard for REST APIs. So if you want to work with, for example, Spotify's API, if we make a call to this URI, this endpoint, their documentation shows us a sample. This is what the JSON response will look like. If you call, let's say, if you call get album, here's the JSON sample of what we might get. So we can try this out pretty easily. We can try two of these methods just in our browser. So if we build our solution, and the scaffold nicely gives us the URL for each method. So if we want all the pets, we just go to API/pets. If we want to get a specific pet, we would go to API/pets and then pass in a pet ID. So we can actually try this API right out in the browser. I'm just going to go to API/pets. And it spits out for us all pets in JSON format, right? If I want to see it raw, I can. My browser has a little JSON parser, so if I want, I can see the nicely formatted and nested JSON. So that was pretty easy, wasn't it, to create a pretty simple API. If I now want to look up a single pet, I could just append on a slash with a valid ID parameter. And now it retrieves, rather than calling that first get method. So with no ID parameter, it runs the get pets method. If I pass in an ID, it runs get pet, which takes in an ID instead. What kind of response will we get if I put in a pet ID of like 2000? So if you look at the get pet method, takes an ID, what should we see if we pass in an ID? It's kind of related to some of the unit testing you guys did in assignment 4. What kind of response will we get if that ID doesn't exist in the database? So if this ID does not exist, right, exactly, we're going to get a not found, which is, so we're going to get an HTTP, a 404 response. So we get a status of not found in this case. But it's still a JSON response. We get a title of not found and a status of 404 from this built-in not found method here. So we can easily test the get methods right in our browser. We want to test the other methods as well. We've got post, which will create a new pet. We've got put, which will update a pet. And we've got delete, which will remove a pet. The get methods, we can execute these in the browser, but we have no simple way to test our post, put, and delete. So we're going to install a tool for this. So there's a tool called Postman. There's a number of other tools, but these are called REST clients that we can use for testing out APIs. So here's the link. Put it in the chat as well, but it's on Blackboard. So you go to postman.com, and you may have to sign up for free, but you may not have to. I'm not sure if you can skip the sign up. So you can download the desktop version of this software. So go ahead and download and install. And then I'll pause the recording for a minute. Give me a thumbs up. I'll just show that again because I wasn't recording. Once it's installed, you click File, New tab. I'm going to paste in my local domain and then add /API/pets. And then I'm going to send my request. Now you may get an error. If so, I'll show you how to fix it. Don't panic. So when I send that, I get a HTTP OK response of 200. And in JSON format, I get all of the pets from the database. You may have an error here, an SSL validation error. Because we're using HTTPS and our certificate is generated by Visual Studio, Postman doesn't like that very much. So if you get an error, you can just click this little red icon here, looks like a globe, and there should be an option to say like accept or trust my certificate or ignore certificate warnings. So if it fails due to an SSL error, because it's saying our certificate is not verified, you can override it by clicking this little red button. And then you can try your request again. So I could also add in a / and an ID number and send. And this time it will run the GET request for a single pet. If I put in an invalid ID, I get a 404 response. Okay, so far we haven't done anything differently in Postman than what we've done in the browser, but we will shortly. Okay, I think this is a good place for us to take a break. I will upload, I mean, all I've done is scaffold this. I haven't changed one character here, but I'll put it up on GitHub anyway. Are there any questions before we take a break? Okay. All right, thanks. So here's what we'll do. We'll take a break here. When we come back, we're going to use Postman to post a new pet. Then we're going to use put to update it. Then we're going to use delete to delete it. And then we're going to look at the Swagger tool that will generate an API document for us that we could give to other developers so they could interact with our API. Okay, let's take a 10-minute break. We will come back just after 12. We should be able to do this fairly quickly. Okay, all the code is on GitHub.